In this recording, we're going to learn how to operate on radicals. So we're going to go over adding and subtracting, then we're going to talk about multiplying and dividing. Give you a chance to write down the heading. Basically, with adding and subtracting radicals, you need like radicals, just like any adding and subtracting. You need like terms to add them. You need like denominators to add fractions. Okay, so it's sort of consistent with other work we've done with addition and subtraction. This radical 3 plus this radical 7 are not like radicals. It's kind of like having an x plus a w. You can't put them together. So this one is already simplified. We'll just write that. It's already simplified. I can't think of any way to simplify the radical 3, taking out perfect squares, or the 7, so I can't do anything with that. This one, however, I've got a certain amount of radical 3's and a certain amount of radical 3's over here. It's kind of like having 6x plus 5x. You'd say it's 11x, right? You wouldn't do anything with the x. You would just say it's 11x. So here I've got 11 radical 3's. Okay, so 11 square root 3. You can check any of these with your calculator by typing in the original and typing in your answer and seeing if they agree. Now we're getting some good stuff down here. Radical 50 plus radical 8. You might say, well, isn't that just like example 1? They're not the same radicals, so we're done. And I would say, maybe. I won't know until I try to simplify each one of these. And if I can simplify them, perhaps they're going to be more like example 2. So let's see. I break down radical 50, just like we did before, radical 25 and radical 2. Here, with the 8, I make it radical 4 and radical 2, taking out perfect squares that go into the radicand. So I circle my perfect squares, and I get 5 root 2 plus 2 root 2. Now I ask you, is it more like example 1 or more like example 2? Hopefully you'd say, wait a second, I've got both like radicals, so it's just 7 radical 2. Right, so that's how it works. You simplify first to determine if it can be combined. Example 4 is just a bit more complicated. You've got a number in front, which you're going to ignore at first, but we're going to recognize that it's being multiplied, right? There's an implicit times here. And we're going to break down the radical 27. So we're just going to leave the 3 in front, and we're going to make it radical 9. Circle that. It's a perfect square. And radical 3. Let's break that down a little further. So I've got a 3 here coming out of that times the 3 in front. That's going to make a 9 overall. So 9 root 3. Okay. And that's going to subtract a 5, and I'm going to break down the 12. So the breakdown of the 12 would be the largest perfect square that goes into 12, 4, and then a 3 is left over. So square rooting the 4 gives you 2, multiplied by the 5 gives you a 10. So now we've created a question like example 2. 9 root 3 minus 10 root 3. You're just really working with the 9 and the 10. So it's negative 1 root 3. If you don't like to write the 1 and just want to write negative root 3, you'd be perfectly correct. Now we're going to get into much easier stuff. Adding and subtracting is hard work. You have to get like radicals. Kind of like adding and subtracting fractions. You have to get common denominators. But multiplying, you don't need anything like that. You just go ahead and multiply, just like we do with our fractions, right? So we just multiply. Multiply the radicands. So you just get 6 times 10, 60. Now you look at this and you say, is there any way I can break this down? And it turns out there is. There's a perfect square of 4 that goes into square root of 60. So we'll take that out. Square root of 4 times the square root of 15. Circle that. That's a perfect square. That means we can square root it. 2 root 15. Again, check this with your calculator. If it's the same decimal, then you know it's correct. Plus, I can't simplify this any further. Hop over to example 6. Just slightly more complicated. I multiply the rational parts here. 2 Negative 2 and 8, I get negative 16. I multiply the irrational parts, the 5 and the 3 that are underneath the square root. I get 15. That's our simplified form right there because 15 has no perfect square factors other than 1, which doesn't help us. In example 7, it's a binomial times a binomial. So if you remember, we're going to distribute here. We're going to do 1 times 2, 2. 1 times negative root 6, negative root 6. Now I'm going to distribute the radical 6. When I multiply these, I get positive 2 root 6. When I multiply radical 6 times negative radical 6, I get negative radical 36, which is really just negative 6, okay? So I'm going to rewrite this. 2 minus root 6 plus 2 root 6 minus 6. We're going to combine our like terms. We've got a 2 minus 6 becomes a negative 4. And I have a negative, let me put a 1 in here if I can squeeze it in here. I've got a negative 1 root 6 plus 2 root 6. Overall, that's just 1 root 6. Just like you can put 1x, that's the same as writing x. 1 root 6 is the same as writing root 6. The 1 in front is optional. There's our answer right here. All right. Lastly, we're going to discuss division. Division's kind of easy like multiplying. We're just going to look for common factors here. Radical 80 and radical 2 share a factor of radical 2. So that just becomes, divide them both radicands by radical 2, I get radical 40. Well, radical 40, does that have any perfect squares that go into it? Sure it does. It's got a 4, right? So we make it radical 4, radical 10. We know that's a perfect square. So it's 2 root 10. Why don't you try example 9 on your own, then play the recording when you've got it. So hopefully you pause the recording and work this one out. What I'm seeing here, 15 and 10 share a factor of 5. So divide by 5, divide by 5. 24 and 3 share a factor of 3. So I'm seeing on the top 3 square root of 8 all over 2. Well, I think square root of 8 can be broken down, so I'll do that. Square root of 4, circle it, square root of 2. That came out sloppy. Let me fix that. All over 2. So I've got a 3. Well, I'm just going to skip a step here. What I have is radical 4 breaks down to a 2. 2 times the 3 that's already outside the radical is 6. 6 root 2 over 2. Well, at this point, I see a 6 and a 2 that have a common factor of 2. So it looks like my answer is 3 square root of 2. Thanks for watching.